Hello everyone, my name is Spencer Hanson and I'm here today to talk to you a little bit about loops. So before today we were only able to execute each block or maybe just a single line of code in our program one time. I'll show you what I mean. So let's say in our main function we have an int x, relationalizing that to the value of 0, right? And let's say we want to increment this variable x 3 times. We would have to do x is equal to x plus 1, x is equal to x plus 1, and so on, right? This can be kind of annoying and definitely take up a lot of lines of code. However, with loops, we're able to execute a particular line or block many different times until maybe a particular event is occurred, or maybe until we've done the loop a certain amount of times. So, we have two different types of loops, which I just alluded to. The first being event controlled, so we were going to continuously loop without knowing how many times we're going to loop until we achieve a particular event or we satisfy a particular condition. Whereas with the count controlled loops, which I'll talk a little bit more about in a little bit, we continuously go, but we know how many times we're going to be executing that loop. So let's say we have the integer from earlier, the int x, declaring that with the value of 0, and then we're going to read in from standard in into that int, right? So it's going to take on a value that the user provides. Now we want to loop through until a particular event. So we have our while loop. This is our syntax, while, and then inside here, whatever's inside here, will be our event, will evaluate to a bool, either true or false. So while this is true, whatever's inside here is true, we will execute whatever inside the block. So we'll have out here. It kind of looks like a conditional, which we've worked with earlier. So let's say we want to increment, kind of similar to before, right? Until x is divisible by 5, okay? So whatever the remainder here is, we'll evaluate to 0, and then since it's being 0, that's effectively false, and then this block of code will no longer be executing. So if we read in, let's say a 5 modulo 5 is 0, this loop will never execute. But we'll continuously execute until we reach the next value that is divisible by 5. So with the while loop, sometimes it doesn't have to just be a single line in here. We can have many different lines. However, it's important that we make sure that we change something so that this condition up here will potentially be impacted. If we were to do something like while true, right? While true, this loop would continuously execute what we call an infinite loop, in that it would never stop. It would just continuously go, and our program would never go to completion. It's also worth noting that potentially, let's say we put this back in the x modulo 5 in here. If we somehow, let's say, forget to increment it, we have some other lines of code in here. This condition will never change. It will always keep the same value of x. So we need to keep in mind when we're doing the while loop. So now with our count control loop, the for loop, it actually sets it up for us a lot nicer. And actually the count control for loop works really nicely with arrays. So I'll use that in my example here. Let's say we have an array int arr. We're going to put 3 values in it. 0, 1. This isn't really important, it's just for the sake of an example. So, with the for loop, for, as you kind of thought, then inside, we have 3 different parts, which are all really crucial to the for loop. So the first part, well, maybe an int I is equal to 0. We can declare this int outside. But if we declare it in here, it will only exist within the scope of the loop. So we'll close it down here somewhere. And we'll put it over here. So now, instead of a comma, which you might see with maybe like a parameter list, we're actually going to put a semicolon here. And then with our array, maybe we want to loop through like the entire size of it, right? So we know it's 3. So we could do I is less than 3. Okay, and then another semicolon because there's 3 parts. Our last part is we're going to be changing this variable x, right? This variable I right here. So we'll do plus plus I. That's just another way we can increment it. So if we're going to go through this array, maybe we check if the value at the array location, so we can do ARR, and then we can actually put I inside here, and we can index in at the spot that is I. We can check if that is equal to, let's say, 1. And then let's say if it is, we want to set it, that location right there, equal to 0. So with this loop, we would be going through each index in the array while this is our condition right here, I is less than 3. So at first, I is 0. We check our condition right here. Is 0 less than 3? Yes, it is. We'll execute this loop. Then at the very end, the last thing we do is we increment increment I. So then it takes on 1, then it'll go to 2, and then it'll finally go to 3, but then we'll check this condition before we execute the loop the next time, and then 3 is not less than 3. So we will never go back through. One thing you want to keep in mind with arrays is that you don't accidentally put like less than or equal right there. So with that is that we would go to I is equal to 3. And in that case, we would be going off the end of the array, and we would be indexing out of the bounds of the array, which we will achieve undefined behavior, which isn't anything we want. So as you can kind of see with this for loop, it sets it up really nicely, as we can kind of see all the pieces here, to loop through and then also increment, so we know how many times this is going to run.